what we're talking about today is our sequences and series. So first of all, let's start by defining what these words actually mean. Okay, so turn your paper over. Let's go ahead and define these words, right? You might have heard them before. In fact, you probably have. Let's go ahead and remind ourselves what they actually mean.
What is that word? Sequence.
Okay, a sequence. Okay, another way we can think of sequence, a list of numbers that may or may not have a pattern. Okay, and we're going to talk about this pattern in a second. A sequence is a list of numbers that may or may not have a pattern.
Oh,
In fact, I think it should have a pattern. Yes, Donovan.
I don't know, it's upon like 1, 2, 3, 4, 5.
Yeah, exactly. Okay, so that's what a sequence is. We have a couple different types of sequences. The first one, okay, I'm going to put a bullet point, is called an arithmetic sequence. Okay, and this is when the numbers have the same difference, meaning they're changing by the same number every time. Changing by the same number, and that it's changing is usually changing by subtraction or addition. That's the key right there. It is changing by subtraction or addition with an arithmetic sequence. Alrighty. Okay, our next type of sequence is called a geometric sequence. And this is one where it's changing by multiplication, okay, or division. Oops, or division. Okay, so what we need to write, because these now have formulas for them, okay? So let's go ahead for our arithmetic sequence. Goodness, I can't spell today. We have what we call an explicit formula for that arithmetic sequence. Okay, and that arithmetic formula is going to be what we call the common difference multiplied to n minus 1, n being the term number. Okay, then we have an explicit formula for our geometric sequence. Thank you so much. And this guy is going to be our A1, which we'll talk about what all these variables mean in a second. That just means our first term, multiplied to our rate and taken to the power of the term minus 1. Okay, cool. All right, so we did a lot of defining. Let's go ahead and just see how these guys actually work. So turn your paper back over. Okay, so let's look at number 1. On our directions here, it says determine if the sequence is arithmetic. If it is, find the common difference, how it's changing each time, the 52nd term, and the explicit formula. We might cut out some of these directions. Okay, so if it's arithmetic, it means that it has the same difference. It's changing the same way each time, either by addition or subtraction. Okay, so let's go ahead and look at this. How would I go from negative 30 to negative 14? What would I have to add to that or subtract to go from negative 30 to negative 14? What do you think? Where'd my calculator go? Okay, well, let's figure that out. Okay, so from negative 30 minus 14, whoops, gotta go the other way. To go from negative 14 to negative 30, let's see, how come I can't think of this? Negative 14, 30, 14. Yes. Okay, that means I would have to add 16. Okay, so let's go put that right there. To go from negative 30 to negative 14, I would have to add 16. Okay, so if these numbers change by adding 16 every time, then we know it's arithmetic. Okay, how do I go from negative 14 to negative 6? Or think 14 minus 6. Did it change the same time?
8.
It added 8 this time. Okay, from negative 6 to negative 2, you'd add 4. Do they have a common difference? Meaning, does that number stay the same? Is it changing the same way every time?
Yes. No.
No, right? Added 16, then it added 8, then it added 4. So this guy is not arithmetic.
Is this easy?
Good, I'm glad. We might kick it up a notch in a second. Okay, so let's go ahead and try number 2. Okay, to go from negative 1 to negative 2, how do we do that?
1.
Negative 1, right? We would subtract 1. To go from negative 2 to negative 6. How would I go from negative 2 to negative 6? What would I either need to add or subtract? I'd have to subtract 4, right? So that right there should tell you, is this arithmetic?
No.
No, it's not, right? It changed by subtracting 1, then it changed by subtracting 4, and then it changed by subtracting...
18.
Yes. Nice mental math, you guys. So again, not arithmetic. If it was changing the same way every time, that would be your common difference, and yes, it would be arithmetic. Okay, cool. Alrighty. Determine on number 3 and 4 if the sequence now is geometric. Okay, geometric means it's changing the same way by multiplication. It has the same what we call common ratio, not common difference anymore, but common ratio. Okay, it changes because now we're multiplying things. Okay, so what we're going to do to find the common ratio is we're going to just choose one term and we're going to divide it by the term in front. So for example, I'm going to choose 15 and I'm going to divide it by the term in front. 15 divided by negative 3. What would we get there?
5.
Negative 5. Okay. So that means to go from negative 3 to positive 15, I multiplied to negative 5. Okay, let's double check that. Let's see if it stays consistent, if they have a common ratio. What is negative 75 divided by 15? Take a term, divide it by the term in front. Negative 75 divided...
Negative 5.
Is it negative 5 again?
Yep.
Okay, that stayed the same. Let's check one more time just to be positive. 375 divided by negative 75.
Like 5 again.
5 again. Beautiful. Okay, so check. Our common ratio is that guy right there. All right. Okay, so there is a way to find, now we need to find the 8th term, and we're going to go ahead and just skip the explicit formula part. Okay, but I will be totally honest. I cannot remember this formula off the top of my head. So here's what I'm gonna do. When in doubt, Google it out. Alrighty. Okay, so we have our geometric sequence. Let's put this formula down on our paper, okay? And if you're like me, probably won't remember it. Good to have it written down, okay? But how we find whatever number of term we're looking for, here's our formula for that. We call it A sub n equals A sub 1 times our rate to the n minus 1, okay? And this is just the explicit formula, okay? But this is what we're gonna plug in to find the 8th term. Okay, so we have, here's what we need. We need the first term, A1 equals first term in the sequence. A sub n equals the term you're looking for. And then R is your ratio. Okay, so those are the 3 pieces that we're gonna need to plug into this formula. Okay, so tell me guys, what was my first term in this sequence?
5 or 3.
-3, okay. So, in order to find the 8th term, A sub 8, we're gonna take -3 times by our ratio. What was our ratio? -5. But that -5 is being taken to the power of now n, which is just the term we're looking for, 8 minus 1. Just a formula that you're plugging pieces of that sequence into. Okay, and now I can just calculate it out. Okay, this is going to turn into -3 times -5 to the power of 7. Okay, you got to take care of your exponent first. So I'm going to do -5 to the power of 7. Okay, that gives me a big number. Okay, they're supposed to be big numbers. And then multiplied by -3. Okay, and that will be the 8th term in my sequence. Okay, the numbers are getting really, really big each time because you're multiplying. Okay, so the 8th term in this sequence will be 234,375. All right, so that one required a little bit of explanation. This one's gonna go way faster. Okay, so we have our formula here, what we need to find whatever term we're looking for. Okay, so go ahead, answer me these questions. What is my first term in this sequence? What's the first number in the list? 2. Okay, so we have that. That one's really easy to find. This one we had to solve for. What's my rate?
6?
Let's see what our rate is. Let's take 6 and divide it by the number in front. 6 divided by 2? 3. Is that going to be the same? Is 18 divided by 6 also 3? Yep. Is 54 divided by 3 also 18?
I'm assuming yes.
Yes. Okay, so our common ratio is 3. Okay, and then again, it just wants the 8th term, so that n is going to be 8. So A sub n equals 8.
I don't like it.
You don't like it? It's a little weird. It's a little weird.
They're so odd.
Okay, so now let's plug it into our formula over here that we circled. Big important formula. Okay, so I have A sub 8 again. And I'll do it in green again. In fact, I'll do it right here where I have some room. A sub 8 equals my first term, which was what?
2?
2 times my ratio, which is what?
8?
3 to the power of
8.
8 minus 1. Yeah, Donnie.
Can I go to that one?
Yes, you may. Okay, so we got to follow PEMDAS here. This becomes 2 times 3 to the power of 7. Okay, then we can just plug this into our calculator. 3 to the power of 7 equals times by 2 equals, and again, it's a big number because you're multiplying every time. Okay, so it's going to be big. So 4,374. So a sub 8, meaning our 8th term in this sequence, will be 4,374. Boom. Okay, so just have this formula written down on your paper. You're welcome. Okay, so now let's look at some arithmetic sequences. Okay, what it's asking us to do here when it says evaluate, it actually means add them together. But before we do this, now we need to go on the back of our paper. Gabe, this is for you. Come grab it for me, bud. Okay, let's turn your paper back over because that was all about sequences. Now we need to talk about series. Okay, the series kind of takes a sequence a step farther. It's literally just the sum of the terms in a sequence. So you're just adding up those terms in the sequence. And that's really all it is. Okay, we have some nice little sum formulas that we're going to use. That's why I like today. It's a lot of just plugging things into formulas, punching it into your calculator and solving. Okay, but let's turn our paper back over. We know that series means we're just adding up the numbers in the sequence. Okay, so turn your paper back over. Let's look at numbers 5 and 6. Okay, now, answer me this, you guys. In your calculator, you could literally just type in 20 plus 29 plus 38 plus 47 plus 56. Correct? Mm-hmm. And find the sum. But what if there were like 20 terms? Would you want to do that?
Yeah.
Yeah, you could. You definitely could. It would take you some time, but let me save you some time. Let's look at the formula. Okay, so the formula, the sum of an arithmetic sequence, S sub n, that just means the sum of however many terms there are, equals n, the number of terms there are, times by your first term, that number term divided by 2. Okay, so have that formula written on your paper. This is the sum of an arithmetic sequence. Okay, these guys are arithmetic because you'll see they're adding 9 each time. Add 9, add 9, add 9, add 9. Okay, so let's just plug in what we know, you guys. So n just means the number of terms. How many terms are in this sequence?
5.
5. Great job. So we're going to plug in our 5 for that n in front. Okay, this a sub 1, that always just means my first term. What is my first term in this sequence?
20.
20. Plus my last term, which is going to be, or the 5th term,
56.
56. Good job.
20.
And divided by 2. Okay, let's just punch this right into our calculator. Once we plug it in, your calculator's your best friend. Okay, so I'm going to do what's in my parentheses first. I have 20 plus 56. And I'm just going to hit enter just to negate any issues. Okay, then I'm going to divide that by 2. Enter, my last step, times by 5. Notice I'm working from the inside of my parentheses out.
240.
190.
Oh, okay.
We get 190. Okay, that
put it in
means
wrong.
we added up all those sums together, and yes, you could have typed in 20 plus blah, 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 and gotten 190, but why not just use a nice little formula to give us our total sum of those
Okay,
terms.
so there's 2 ways you can do it. You can do it like this, or you can just add
Punch
them
it
all
in.
together.
Yep,
Oh, okay, cool.
that would have been easy. I mean, when you have like 3 or 4 terms, you could definitely do that.
Okay.
If you have like 20 terms,
Don't
might get a little
just do that.
monotonous. Yeah.
Okay.
Okay, but let's try it again. Let's try using the formula again. I'm all for formulas. They should make our life easier. Okay, so we need our number of terms. Okay,
This is
how many number of terms are in this sequence?
3.
1, 2, 3, 4, 5, 6, 7. Great job.
You didn't believe me?
I'm just double checking. I believe you. Okay, then I need, in my parentheses, my first term.
7 and then the 31 and 2.
Nice, and then divided by 2. Look at you guys go. See, once you have the formula, it's pretty
So 2.
pretty self-explanatory.
It's 31.
Why does it say 22.5?
Do you divide it by 7?
Okay, so watch the order. I'm gonna do my numerator inside my parentheses first. So I'm gonna take 7 plus 31. Okay. Then I gotta divide that by 2.
Oh,
And then it gives,
19.
oh, 19.
And then
97.
multiply by 7.
133.
So if you were to add up all those terms, you'd get 133.
That was probably the easiest
Okay.
one.
Yeah, not bad. The others aren't too much harder. It's just a different type of sequence, right? These guys were arithmetic, where it's adding the same number each time. Now, we're going to find the sum of a geometric sequence. Okay, and honestly, it's just another formula. Okay, so we have our geometric sequence here. Tell me, guys, let's find the rate because we got to know how it's changing each time. So let's take -6, divide by -3. What is my rate here?
Oh. 6. Oh, divide.
Mm-hmm.
-2.
2, positive 2. Okay, so my R equals 2. My rate equals 2. Okay, and it wants us to find the sum up until the 9th term. It doesn't give us all 9 terms, but it wants us to find the sum of those 9 terms. Okay, and we can do that. We just need the formula. Okay, so are you ready for it? Here we go. S sub n, again, just meaning the sum of the number of these terms, equals my first term, a sub 1, being multiplied 1 minus r to the nth, it's my numerator, over 1 minus r. Okay, that looks like a super complicated formula. It's not once you plug in the numbers that you need, okay? A sub 1 is always just that first term. N is the number of terms we're working with, so this time it's going to be 9, right? N equals 9. R is what we just found, our rate. Okay, so let's go ahead and plug it in. Okay, so I know my first term is what? What's my first term in this sequence, or this series, I guess? Sequence, series?
3.
-3. Then in parentheses, on top I have 1 minus, what was my R again? What was my rate? How's it changing
2.
each time?
2.
Positive 2 to the power of how many terms I'm working with? 9. Divided by 1 minus 2 again, my rate of 2.
Oh.
Okay, it's okay. Let's just solve, right? You're freaking out. That's totally fine. Let's make these prettier. Okay, so first of all, I want to figure out what 2 to the 9th is. Okay, in fact, let's just take 1 minus 2 to the 9th. That's my whole numerator up there. Okay, so that whole numerator inside my parentheses turns into -511. What's 1 minus 2? What's my denominator?
-1.
-1. Okay, well, -511 divided by a -1 just turns into +511. What's my last step? What do I need to multiply to that 511? What's the last thing I need?
3.
The -3. Okay, so I'm going to take 511 times by -3. And there is the sum of 9 terms. Big number. It's because these numbers are multiplying each time. They're getting bigger. So obviously, if you add them all together, it's going to be a big number. So the sum of this guy is
That's all for 7?
mm-hmm.
What?
And we'll go ahead and skip number 8.
Oh.
since I used all of its space anyway.
Because now this decided to be really long. And
Yep.
I'm not now.
So it's just the formulas. I know. It's formulas. A lot of formula work today. Okay? Numbers 9 and 10, these guys are actually pretty nice. The words are kind of weird. Okay? It says, determine if each geometric series converges or diverges. Okay, well, let's go ahead and define what that means. Converges means the rate or the common ratio is less than 1. So if the rate that you get is a number that's less than 1, like a fraction, then you're going to know that this series converges. Okay, diverges is the opposite. It means that the ratio is more than 1. Okay, so let's go ahead and try this guy out. Okay, so in order to find the rate, you guys know how to do that. We just need to take a term and divide it by the term in front. Okay, so this guy is going to be a little weird. We're going to take -9, divide it by 6. This is a fraction. Okay, but you guys know how to reduce fractions. How can I reduce that fraction? -9 divided by 6. What can I divide both 9 and 6 by to make them smaller?
3.
3. Good job. That would give me -3 on top over 2. There's my rate. Now the only thing you need to ask yourself is -3 over 2 greater than or less than 1? Think on a number line.
Less than? Or
No,
greater?
greater.
Greater.
Let's see. So 27. It is greater, right? Because 3 is greater than 2. Okay, so since it's greater, is this guy going to converge or diverge?
Converge. Diverge.
Diverge, because it's bigger than 1. Boom. Okay, let's try that again. That's all you're doing. Just seeing if the rate is
Wait.
bigger or smaller than 1. Okay, so let's do that again. We're going to take a term, and we're going to, let me change my color. Take a term, divide it by the term in front, so -162 divided by 486. Okay, and I don't really feel like reducing that, so let's just see what we get in decimal form.
-0.33333.
-162 divided by 486. Yep, you're absolutely right, which is also -1/3. So tell me, you guys, is 1/3 less than or greater than 1?
Less than.
It's less than. So is this series going to converge or diverge?
Converge.
Converge.